Hello my dear children of class 11 science. Today again we do continue with the chapter that is heat transfer. So this chapter is important chapter as far the transfer of heat is concerned. Okay, because we started this chapter with the concept of what? Conduction, convection and radiation. Okay, but out of three mode of transmission of heat, one of the important mode of transmission heat in which there are number of phenomenon or one number concept that has been added and has been explained is called radiation. And children, we are still in the concept of radiation, and basically related to this radiation we are learning the terms related to radiation. Okay, so in the last class we learned up to the term called emissive power. Okay, now there is another term that we need to define, and that is called emissivity. This is called emissivity. Now emissivity is actually defined as the ratio. It is actually defined as the ratio of total radiant power. The total radiant power is also called emissive power. What power? Emissive power. Okay, of a body, okay, to the total radiant power only of a perfectly black body. So there is a difference between a body, ordinary body, and the perfectly black body. Now ordinary body can emit radiation, okay, and absorb radiation. But perfectly black body absorb all the radiation which is falling on it, and perfectly black body emits all the 100% radiation that from it. Okay, but ordinary body cannot emit all the radiation. Okay, but even with the ordinary body and the perfectly black body, there is some amount of some amount of energy that is emitted from the surface, and this energy which is emitted per unit area of the surface per second is actually called as radiant power, also called as emissive power, and that we have already learned in last class. Okay, so just to write the definition, what is emissivity, let me just write it down. And the definition says that it is defined as the ratio of total radiant power, okay, or emissive power of an ordinary body, okay, to the total radiant power of our perfectly black body. And you know, perfectly black body emit all the radiation. Okay, but ordinary body cannot emit 100% radiation. Okay, but the amount of radiant power, okay, emitted by the ordinary body can be compared with respect to what? Radiant power emitted by the what? Perfectly black body, and that ratio is actually expressed by the term known as emissivity. Now emissivity is basically symbolized, and I know it is denoted, okay, by E. So this is actually E, also we can also call epsilon. Okay, this also use the word like epsilon, so it is denoted by letter this. Okay, now I write down let E, as we have already used the symbol, small letter E is the what? Is the radiant power. This is the radiant power, okay, of a what body? Ordinary body. Now I write down capital E as the symbol. This is also the radiant power. This is also the what power? Radiant power. Now radiant power, as I said, is the amount of radiant energy emitted per unit area of the surface per second. Okay, so E is the radiant power. Let me write simply as radiant power of our body? Perfectly black body. Perfectly what? Black body. Then as for the statement which I had written out here, okay, this statement says that that emissivity, okay, emissivity, which is marked by symbol this, is also is given by what? E by capital E. So I am writing with the symbol out here. E is the radiant power of an ordinary body, okay, where capital E is the radiant power of a perfectly black body. So the ratio of this radiant power expressed in with respect to another ordinary body and the perfectly black body is actually known as emissivity. Now this quantity has no unit. It has no unit. Now why it has no unit, children? Because it's the ratio between two similar quantity. But the value of emissivity actually determines the nature of the body also. It also determines the nature of the what? Body. Okay. Now if emissivity is exactly 1, if emissivity is exactly 1, then we understand that the body is a what? The body is a perfectly black body. Perfectly black body. Or we also call this as ideal radiant. Okay, this is also called what? Ideal radiant body. Okay, we can use the word ideal radiant body. Okay, so perfectly black body can also be called as ideal radiant body. So for perfectly black body, this value of emissivity is 1. So that if emissivity is 1, then this E equals to small e. Okay, so whatever total energy, radiant energy or emitted per unit area per unit time, okay, that is also called radiant power, is exactly equals to the energy emitted by the what? Or body. And that energy emitted by the body is exactly equals to E. That's why that body is also called as what? Capital E, and that's why that body is also called perfectly black body. Okay, whereas if emissivity is less than 1, then this emissivity less than 1 is for what body? Ordinary body. We can use the word ordinary, or we also use the word practical radiant body. Practical radiant body, or also simply called as practical radiant only. But for perfectly black body, emissivity is always equals to 1 with no unit. So this is very important. Now children, we have a last term to define as per the radiation is concerned. Okay, and this is spectral absorptive power. Okay, spectral absorptive power, and this is actually symbolized by letter A lambda. So actually A is the symbol we used last time for in one of the term is called absorptance. Okay, and that's why it is also called as monochromatic absorptance, also called spectral absorptive power, and it is actually defined for particular wavelength range. So what is actually spectral absorptive power? It is also defined as the ratio of the amount of heat. So just try to understand, is the ratio of the amount of heat energy absorbed by a body, any body, is the ratio of the amount of heat energy absorbed by any body per unit wavelength range in a certain time, in a certain what time, to the amount of incident heat energy on the wavelength range in the same time interval. So how much total amount of heat which is incident on that body in a certain time interval, okay, on that particular wavelength range, so that how much amount of heat energy that is absorbed by that body per unit wavelength range in the same certain interval of time, and that particular ratio of the amount of heat absorbed by the body per unit wavelength range in the certain time to the amount of incident heat energy, okay, in the same wavelength range in the same time is actually measured by the term known as spectral absorptive power. So this particular term is actually measured for a particular wavelength range, for a certain wavelength range in a certain time interval. So in a certain time interval on a certain wavelength range, definitely a body can absorb certain amount of heat with respect to the total amount of heat which is falling on the body, okay, and that ratio is actually measured by the term known as spectral absorptive power, and this is also sometimes known as monochromatic absorptance. Okay, now this is symbolized by letter A lambda. So A with lambda indicate the spectral absorptive power. Now this is also the ratio between two similar quantity, the amount of heat absorbed and the amount of heat incident on the body. That's why it has no unit. It has no unit. So the term like emissivity you learned just now, and the term like spectral absorptive power are those physical quantity which has no unit. Remember this. Okay, so I have explained in detail about the terms, the different terms which might ask in the examination related to what? Radiation. Related to what? Radiation. Okay, now in the next YouTube video we learn a very important law, a very important law that is called wind displacement law.